You had Obama make those comments about the subject of aliens.
They're real, but I haven't seen them, and they're not being kept in Area 51 unless they hid it from the President of the United States.
I think he was joking when he said there are aliens he's just never seen.
No. Obama is scientifically literate. But if you have the aliens and you don't want the president to know, the president's not going to know.
So do you believe there's intelligent life in the universe?
Well, we have whistleblowers saying we have actual aliens. People have testified we have aliens, that we have alien crash parts, so I don't see why they wouldn't be given the size of the universe.
And Neil deGrasse Tyson, what is the most pressing question that people are asking right now about the universe? And the first thing I wanted to ask is, why are people so interested in going to the moon?
It's geopolitical. China says they're going to the moon 50 years after we go to the moon, and we all of a sudden decide we want to go to the moon?
Is there an economic upside to it?
No.
Talking about data centers.
No. I already answered you. I said we don't want them to go to the moon without us going to the moon.
And there's no laws up there, is there?
Space law is a Wild West at this point. It's like who owns the moon?
Nobody.
Well, they're trying to figure that out. But don't delude yourself into thinking we ever went to the moon for science, then or now.
Okay, next. Do you believe that we're in a simulation?
I'm whiny about that, and I'll tell you why.
And then, can you explain what a black hole is, like if you get sucked in?
Okay, so you will see the entire future history of the universe unfold. And then the difference in gravity between your feet and your head gets greater and greater and greater. Eventually, you'll snap into two pieces, likely separated at the base of your spine. And that's not even the worst part, and we'll get to that.
And then, just how small are we? Is there a most compelling UFO sighting that you can recall? Has your view of religion changed through all that you've learned about the universe? And what is the point of life?
Wow! You asked a good question. So, let's get into this.
Guys, I've got a favour to ask before this episode begins. The algorithm, if you follow a show, will deliver you the best episodes from that show very prominently in your feed. So when we have our best episodes on this show, the most shared episodes, the most rated episodes, I would love you to know. And the simple way for you to know that is to hit that follow button. But also, it's the simple, easy, free thing that you can do to help us make this show better. And I would be hugely grateful if you could take a minute on the app you're listening to this on right now and hit that follow button. Thank you so much. Neil deGrasse Tyson. People come to you to try and understand the universe.
Yes.
What is the most pressing question people are asking you right now about the universe?
Are we alone in the universe? And that's influenced by pop culture. I'll give you an example. When the movie Ghost came out, polls showed that more people believed in ghosts after that movie than before the movie. So pop culture is a huge force of influence on our thoughts and feelings and attitudes and what we believe is or is not true. So when you say, what is the most pressing question? Are we alone in the universe? Then they say, have we been visited? And how will it all end? That's another one. Usually God shows up in there. Is there God? There's an assumption. I think it's a naive assumption, but an interesting one nonetheless, that people who study the universe might stumble upon God because we're told, or at least in our artwork, gods live in the sky. So people then study the sky. When the Apollo astronauts came back, people said, did you see God? Did you see heaven?
What is the essence of why people are so curious about these subjects?
My best speculation, and this is a wild speculation, and my ego is not based on whether this is true, but it's fascinating for me to think about the fact we are completely comfortable sleeping on our backs. Ask yourself, how many other animals do that at all? Does a beetle say, I'm going to turn over and go on my back and go to sleep? Do spiders just go on their back? Think about it. That's quite vulnerable. You're asleep and your belly is exposed, right? We sleep at night, typically. Okay. If you're outdoors, us sleep on your back at night and you wake up. What's the first thing you see? The universe, the sky. You'll see, comets and meteors and the moon and brighter stars, which we call planets eventually. And from night to night, wait a minute, the moon had one shape and now it's a different shape and it's a different part of the sky. And these lights are moving. And how could we not be curious? When in the middle of the night you wake up and the universe presents itself to you. So I think that's sort of in our DNA, the curiosity about the night sky. I didn't make people interested in the universe. In fact, when I was a kid, my first encounter with the night sky was a planetarium, the Hayden Planetarium here in New York City. I said, wow, I want to study the universe. But the universe is so interesting. Everybody's going to want to study the universe. And there'll be no room for me. And as I got older, I realized there are other things people are interested in. Not everybody wants to study the universe professionally. However, whatever you choose as a profession, it doesn't change the fact that somewhere in you, you're going to look up and say, what does that replace in the universe?
I thought you were going to say, when you talked about sleeping on their backs, that we are now so comfortable being the sort of apex predator that we're able to sleep on our backs. And actually, we're so interested in aliens because it's the only thing that would threaten our place as being able to sleep on our backs as the apex predator.
Oh, yeah. I don't know that ancient people were dreaming up aliens. It's just the night sky itself. Well, okay. Let's not use the term alien. Let's just use the term gods. Mm-hmm. Where are most people's gods? They're in the sky.
Yeah.
Even in ancient Greece, they're Mount Olympus, not in the sky, but they're in high places. If you look at posters with religious sayings on them, typically it's a sunbeams coming through clouds and a beautiful landscape. You're looking at the sky. And by the way, what are our images of deity? Many of them could pass for aliens, like the Gorgons, for example. Look at Medusa, snakes for hair Medusa. That's as alien as anything you would ever conjure. What else? Images of Jesus. He's floating. He's got beams coming out of him. If he's not floating, he's walking on water. These are things that go beyond anything that's earthly. So now people imagine aliens with all these same powers and weirdnesses. So I don't know that alien is something specific that's in our DNA to think about, but to imagine things beyond ourselves is. And so I would lump them together in that respect.
One of the things that made me, I guess, more curious about aliens and meaning and purpose and gods and all these things was watching Cosmos, which was your series around the universe. And specifically, it was...
And Carl Sagan did it first.
Carl Sagan, I watched
my
both.
series.
Well, I watched both.
A series I happen to host, yes.
Yeah.
Okay.
And they both had the same impact on me, which was they made me feel insignificant in the grand scheme of the cosmos. I think when you realize how insignificant we are, or small we are, should I say, in this grand scheme of even this Milky Way galaxy that's on the table in front of us, the delta in the size of me and my world versus all of this is mystery. And I almost feel called to fill it with something. Is it Parkinson's law where you fill the space provided? It's the same thing with the universe. Just how small are we, Neil, in the grand scheme of the universe?
Well, if you don't think in terms of metric size, how big are you? Are you this big, this big, this big? If you think in terms of powers of 10.
Okay.
So there are things 10 times bigger than us, 10 times bigger than that, 10 times bigger than that. You just keep doing that. Mm-hmm. We're small compared with the universe, but we're huge compared with atoms and molecules. Now, instead of going 10 times bigger, go 10 times smaller, 1/10 to be precise. What's 1/10 our size? Well, that's this big. 1/10 that is that big. 1/10 that. You keep going down, you enter the realm of molecules and then atoms and then particles. So there are things much smaller than we are. In fact, I addressed some of that I wrote an alien book recently, Take Me to Your Leader. There's a lot in there about changing your perspective on what you might expect life forms to be like out there. So you can ask the question, are the life forms the size of a galaxy? Or are the life forms the size of atoms? Are we just biased by what our senses can drink in from our own size scale? And that's an interesting fact. And so you know who'd feel small if you were a life form the size of molecules. Okay? Then you're feeling small. There's not much smaller than you if you're molecular size life. Now, we don't know how you would make that because life, by our own understandings and definitions, it has a metabolism. There's things that happen. You ask a biologist what is life, they'll give you a list of criteria, which are hard, if not impossible, to be fulfilled by life that's extremely small. And they still debate whether viruses are alive, right, based on some criteria. But some had speculated that life could be the size of nucleons. So a nucleon is the size of the particles in the nucleus of an atom. Things happen very quickly on that scale. So they might wonder, how is it that we live so slowly? So inverting your expectations is a time-honored exercise in keeping you honest, keeping your ego in check.
You can go the other way, right? This whole universe could be something in another life form's gut microbiome.
Yeah, okay. So that was briefly addressed in the film Men in Black. Okay. What I can say is the laws of physics manifest differently on different scales. So you can't just scale everything up, which is why you don't have human-sized insects. Their legs would break under their own weight. It's why heavy animals have thick, chunky legs. It's why if you fell off the roof, you're dead, but an ant can just land and keep walking. Okay? Forces don't interact in the same way depending on your scale. One of my favorite scenes in the film A Bug's Life, which I think that was a Pixar film. Pixar, they must have a room full of scientists working for them. There's a mosquito at a bar. So the mosquito orders a drink. So what drink does he order?
A mojito? I don't know.
A Bloody Mary. Of course. It's okay. How big is a mosquito? It's this big. And it's a bar. It's like an insect bar. And so the bartender brings over the Bloody Mary and just puts a blob of the liquid in front of it. It's not in a glass, not in a jug. It's just, there it is. Because surface tension is something that manifests in ways that insects care about greatly, and we don't, unless you're waxing your car, and then this water gets on it and it beads up. Okay? Surface tension is a property of liquids, where the outer surface, the molecules are a little more tightly gathered because they don't have forces above them to pull them into the solution that is the liquid. So transitioning from the liquid itself into air creates a kind of a film, all right? And it holds the liquid in place. Unless there's too much liquid, then gravity becomes stronger than the surface tension. And it just flies. Exactly. But below a certain amount, the surface tension is greater than the gravity. And it beads up. So they knew this in that movie. And I thought that was brilliant. My only point of this is to communicate that you can't just scale things up and expect everything to be happening in exactly the same way. But I want to get back to your point when you said you felt small after you saw Cosmos. You only felt small because you went in there with an ego that was unjustifiably too large to begin with.
Probably.
I'm accusing you of that.
Probably. Yeah.
However, I go in there with no such ego. Okay? And I look up at the stars and I learn from modern astrophysics that the elements in our body were forged in stars that exploded, the elements, the oxygen, the carbon, the nitrogen, the iron that courses through our blood was forged in stars that at the end of their lives exploded, scattering that enrichment into the galaxy, out of which the next generation of stars and planets are formed. Early in the universe, we didn't have these ingredients. We could not exist as in our current form. So, when I look up, I don't feel small. I feel large because I'm connected to the cosmos chemically. And that connectivity, let's make it a little more poetic. Not only are we alive in this universe, the universe is alive within us. And that fact borders on the spiritual. There's an astrophysical fact that gives you a pathway of relevance to the universe. We are part of this great unfolding cosmic story. The fact that we are made of elements forged in the stars. Next time you go out and look up, I want you to feel large, not small. Because we are not only made of what stars have produced, we are solar powered. What do I mean by that? Okay, if you're omnivorous, you maybe had a steak last night, okay, that you're getting calories from the food you eat. And the steak was once a cow, okay. What did the cow eat? Cow ate plants. What do plants eat? Well, they don't eat. They just sit there and receive sunlight. So a cow, I said this once on the internet and freaked people out. I should not shy away from speaking truth just because it freaks you out. A cow is a machine that we invented, because cows don't exist in the wild. It's domesticated. A cow is a machine that we invented to turn grass into steak. So, because at the end of that chain is grass that has photosynthesis, essentially 100% of our caloric value is traceable to stars, specifically the sun. So you are solar powered and the universe is alive within you. So don't ever sit across from me again and say, I feel small in the universe. Sorry, you have a lower pitched voice than that. I feel small in the universe.
It's strange, isn't it? This idea of like significance as a concept, like trying to understand one's significance. And I think religion often gives us a sense of significance.
Well, it does. Yes, of course. Hence its value to people and its persistence throughout time and across cultures.
Has your view of religion not changed through all that you've learned about the universe in any way since you were this? I've got this photos of you as a young man.
What's that? Oh, you did some homework there? What'd you do?
I've got so many photos. I mean, I've got this one here of you and you. I mean, this one's a fascinating. I love that one.
Okay.
My hair was like this when I was that age.
Oh,
so.
Yeah. So this one was my first telescope, and that's my father helping me put it together.
If I think about this young man here and what he thought about religion, are you more religious, less religious? If so, why?
So, by the time I was 8, nothing was making sense that people were telling me about religion. What I didn't know is that belief systems don't have to make sense. That's why they're belief systems. If they made complete sense, it would just be objectively true. If it's a belief system, then it's beyond critical analysis. It's just a belief system, okay? So when I say beyond critical analysis, what I mean is if something in your belief system lends itself to be tested, we can test it. And if what we test shows that what you believe is false, are you going to stop believing? Generally not, because it's a belief system, okay? Most people want to engage you ultimately with some kind of spiritual religious conversation, I have found, especially given my access to the universe. And in the early days, there were easy answers. It was like, this is religion, go ahead, I'm doing science here. Then I thought, I owe people who are religious a more informed and nuanced engagement because of the power and force that religion has exercised on the history of the world. It's not just cultural, it's political, it's economic, So I started reading religious tracts. And now when I'm engaged in a conversation, I have a full-up conversation with people on their beliefs, whatever intersection, if any, with the objective universe, and what those beliefs do for the person who holds them. And there are many places on the internet that claim me as an atheist. And it's like, I've never embraced that title.
So you're not an atheist?
The only ist I am is a scientist. Okay? Let's start there. Now, titles are lazy. I'll tell you why. Once you hand a title to someone, that gives you license to not have to think anymore about who and what that person is regarding that subject. And that has never ended well, in my experience. So, first, it's odd that such a word as atheist exists at all. Think about it. It's a word that says what you're not. Is there a word for non-golfers? Is there a word for ask yourself, how many things do we have words for which you're not? Very few. And so this exercise of saying you're either with us or you're against us. And if you're against us, I have this word for you that says you're not this. Like I said, that never ends well. It ends in war and bloodshed, typically. Leading atheists today who write books on this, okay? Richard Dawkins is among them. He wrote a book called The God Delusion. That's fighting words if there ever was one. These are people who reject God, reject its influence on politics and society and lives, and would just as soon see a world without it. I'm not that guy. I have behavior that would be rejected by any modern atheist thinker. So what am I? We pick the next word would be agnostic. Okay?
Okay, so let's pick that next word, which I also relate to. I would consider myself to be agnostic as well.
Agnostic. Sure.
I just don't know. What's your leading view of where all of this stuff came from?
It's consistent with observations and experiment. The Big Bang.
The Big Bang.
Oh, it is so thoroughly supported, as fantastical as it is.
Explain the Big Bang to me like I'm 15.
I'll explain to you like you're 12.
Okay, please. Okay. Even better.
So approximately 13.8 billion years ago, everything that you see and interact with in this universe began in an infinitesimal point. That is the birth of the space and time of our universe. We have been expanding ever since. Now, how does something that big ever become that small? Well, it's not matter trying to occupy the same space as itself. Energy can be essentially any size compacted, and then you can measure what's there by what the temperature is. And so it's very hot fireball, basically. And as it expands, it cools, and the cooling energy makes matter. It's equals mc squared. Energy on one side, mass on the other side. This c squared is just the speed of light. It's just a constant. But Einstein came up with this in 1905, and it made so much of the universe make sense at that point. And so, and it would take a while. We expand. We cool enough to make stars and galaxies, and we're still expanding to this day. There are mysterious forces operating that we don't yet understand, what we call dark energy. That's a pressure in the vacuum of space, making us expand faster than what would be allowed by the collective gravity of all the galaxies. That's a frontier question that is not yet resolved. Then there's sources of gravity that we don't know what's causing it. We call that dark matter. If you add up dark matter and dark energy, it's 95% of what's driving the universe. So everything you and I know and love about the biology, chemistry, physics, astrophysics, forces, food, calories, molecules, solids, liquids, gas, it's 5% of what's going on in the universe. That's amazing. And this is why when I began, I said to you, sometimes I wonder whether we're smart enough to figure out the entirety of the universe, or do we just figure out our little fraction of it and live happily ever after within it. Now, that scenario, you have full rights to ask, what was around before that? So ask me that.
What was around before the Big Bang?
We have no idea.
Okay.
Well, we have suspicions. There might have been a multiverse, which has come out of latter-day mathematics related to quantum physics and Einstein's relativity. What comes out of those equations is a multiverse.
What's a multiverse?
It's this medium that is pumping out universes. We are just one of them.
What caused the multiverse?
We don't know.
Eventually,
it's a frontier. There's no crime in asking the question at the frontier of our knowledge. There are people who have to have answers. They don't make good scientists. The urge to have an answer can be influenced by their bias, by their culture, just take a look at all around the world, the origin stories. The origin stories flow out of the cultures from which they emanated.
What are your untested, unverified, untestable ideas about where all of this universe stuff might have gone? Because I know you must sit at home sometimes and just mull. You do a lot of mulling about the origins of the Big Bang and those things.
Well, we all do. So when you confront the unknown, you write the recipe for more data. That's all it is.
And what are those recipes that you've written?
We need a telescope. We have telescope. I haven't written. I mean, my field has written them. We have telescopes specifically designed right now to get a better understanding of dark energy and its manifestation throughout time in the history of the universe.
Explain dark energy to me.
No, it's something in the vacuum of space that's making the universe accelerate in its expansion.
Okay.
From that original explosion, we have all the galaxies, all the matter, all the gravity. You expect the expansion to be slowing down at some rate based on the gravity.
Oh, but it's speeding up.
It's like tossing something in the air. Gravity of Earth slows it down and actually makes it reverse. So we expect that. We went to make that measurement and we got the opposite answer. The universe is accelerating. That won a Nobel Prize. 1998 Nobel Prize. It's a term in Einstein's equation that he rejected. So there can't be a negative gravity. Its value in his equation must equal 0. And so let's move on. Then we discover it. We come up with a term for it. I think it's a bad term. Bad because it leaves the witness. We don't know what it is at all. So don't call it dark and don't call it energy. Call it Fred. Okay? Something. And dark matter, we don't know what that is either. Okay? Let's call that Wilma. We got Fred and Wilma. We don't know what it is.
There should be a button just down below here. And if it says subscribed, you're already subscribed. If it says subscriber, that means you're not yet. And if you're not subscribed, please could you do us a favor and hit that button. It helps the show more than you know. And according to the algorithm, you're someone that watches our show, but you haven't yet hit that button. Thank you so much. So the key question I think that people are talking about at this moment in time, because you had Obama make those comments in that interview saying that he was joking. I think he was joking when he said there are aliens he's just never seen.
No. First, A, Obama is scientifically literate. It's A. B, he said, because he's scientifically literate, he said what is scientifically defensible, that there are probably aliens in the universe. Anyone who studied that problem will arrive at that conclusion.
They're real, but I haven't seen them, and they're not being kept in, what is it?
Area 51?
Area 51. There's no underground facility, unless there's this enormous conspiracy, and they hid it from the President of the United States.
That's what he said. But as former President of the United States, and we have sort of alien-adjacent culture, it was, that must mean there are aliens in the basement of the White House or somewhere in government custody. They took his statement that, sure, there are aliens out there and turned it onto the U.S. government. And when I heard his comments, that's exactly what any scientifically literate person would say. What people did with that information, he then had to come back and explain. I didn't even think that was necessary, but apparently it was.
And then Trump responded.
Okay. Mm-hmm.
On Air Force One in an interview and said,
well, he gave classified information. He's not supposed to be doing that. You know?
So aliens are real?
Well, I don't know if they're real or not. I can tell you he gave classified information. He's not supposed to be doing that. Well, he made a big mistake. He took it out of classified information.
Trump seemed to stoke the idea that there is aliens. And then from that, shortly after, we had the UFO files announcement.
Sure, great. Bring them out. I love it.
They were going to release the UFO files. And now we find ourselves at a place where the general public is, again, really, really curious about the subject of aliens. And you see it on the Google Trend data, which I've got in front of me here. You see the up, the down, the up, the down, based on what people are talking about. So my question to you is this central question, which is, do you believe there's intelligent life in the universe?
So one of those peaks in May, in part, was because there were files released that week by the Pentagon. And dare I suggest, my book was released in May, on May 12th.
Good timing.
Yeah, it just turned out that way. I decided to jump into the ring, not jump in, put a foot into the ring, more accurately, when I saw these high-ranking whistleblowers come forward in Congress, sworn testimony. Whistleblowers, former intelligence officers, former military folk. And I said, all right, it's time to jump in, because no longer can you discount the testimony the way you might have done so before with the farmer in the back 40, who saw something and is talking about it, but didn't take a picture of it. All right. All these testimonies that have existed in the past and accounts of UFOs, now when official government people are doing it, then, all right, it's time to take it up a notch. And what do I mean by that? Bring out the alien. If you're saying you got an alien in the shed, in the back 40, just bring it out. And the moment you do that, no one will ever have to ask again, do you believe in aliens? That's the question I've been asked. Do I believe in aliens? No one has ever asked me, do I believe in elephants? Why? Because we've shown elephants. Okay? We have elephants. You've seen elephants.
But do you think there's intelligent life in the universe?
I don't see why there wouldn't be, given the size of the universe and the age of the universe and the ingredients of the universe. I mean, think about it. In the early Earth, life got underway within 100 million years of as early as it possibly could have. That sounds like a long time, and it is, but that's small compared with the timeline of Earth itself, of life on Earth. It's like 5% of the timeline of the Earth. Almost as fast as it could possibly happen, the basic ingredients on Earth, which match the basic ingredients of the universe, went from organic molecules to self-replicating life. Whatever our challenges in the lab, Earth didn't seem to have a problem accomplishing it. And so look how quickly that happened. Yes, it would take a long time, much longer, to generate what we're calling intelligent life. But given how many planets are likely in the galaxy, our catalogs now have 6,000 exoplanets in them. And that's just in a tiny little area. That'd be in a little circle, that'd be in a little, if the sun is here, do a little bee circle around it where we've searched for exoplanets, and we got 6,000 just in that little.
What's an exoplanet?
Exoplanet, planet orbiting another star.
Oh, there's 6,000 in a little.
We've cataloged 6,000. In 1995, what year were you born?
92.
92. So you were 3 years old when we discovered our first exoplanet.
Really?
Yeah.
Wow.
And now we're rising through 6,000. It was banner headlines back then, not today. But if life happened on Earth as swiftly as it did, no one among us who've studied the problem are given reason to doubt that it couldn't happen frequently elsewhere in our galaxy or in the trillion other galaxies in the universe.
This is just the Milky Way galaxy.
This is a version. Yeah, this is, if you could step out of our Milky Way, it would resemble this greatly.
This is one galaxy, right?
One galaxy containing hundreds of billions of stars. This cloudy thing, you cannot resolve the cloud into the individual stars. Galileo did this. He said, I wonder what that Milky Way is. Is that just a cloud? Took his telescope, put it on the Milky Way. He saw individual stars.
And how many galaxies are there in the universe?
100 billion stars in a galaxy, at least 100 billion galaxies in the universe.
Is the answer that we just don't know how many there are?
Let's quantify what it is to not know. In the universe, things range over such a huge scale that if you're off by a factor of 2, which sounds significant in most everyday life, but if things range over factors of trillions, then if you can get an answer within a factor of 2, you're doing really well. You have a basic understanding of structure, space, and time. And so our galaxy has several 100 billion stars in it. No, we don't have an exact count, but that's a very good estimate because we know the total mass of the galaxy and we know how much mass a star occupies. We know how much dark matter there is. So we can calculate the likely number of stars there are in the galaxy.
Planets?
So now, given our data on planets that we've obtained, we have many star systems with multiple planets. And that's just in our neighborhood. So if that's representative, then you just scale that up. So if you looked in that little zone everywhere and just up the number, you end up with millions of planets, possibly billions across the galaxy. That's how you would estimate that. So it's not knowing the exact answer is not the same thing as having no clue.
And there might be hundreds of billions of galaxies.
Yes, yes. Not just might be. There's at least that many. In the observable universe, the actual universe goes beyond our horizon in the same way for a ship at sea. You have a horizon.
Mm-hmm.
Are you saying to yourself, well, that's the edge of the earth or that's the edge of the ocean? No. You keep sailing and more ocean comes in view.
Is it infinite?
It might be. We don't know. You're asking all good questions. And you're going right to the edge of what we don't know.
Is it possible for something to be infinite?
I'm not going to put a prerequisite on the universe that it's not. Just because infinity is kind of hard for the human brain to wrap your head around doesn't mean the universe can't or shouldn't be it. We've made assumptions about the universe just to be consistent with our own philosophies that just turn out to be flat wrong. Copernicus, a religious man, comes up with an idea that maybe the sun is in the center of the known universe and not Earth. So we go from geocentric to heliocentric. All right. Well, if you do that, then we don't have epicycles. All right. Then we just have orbits, simple orbits around the sun. Well, he did that. You know, it didn't match the observations as well as the epicycles did. So do you throw out the whole idea? No, we would learn later, 50 years later. The orbits are not perfect circles. He made them perfect circles because it's the universe. God created the universe. God is perfect. The circle is a perfect geometric shape. Clearly, anything moving in the universe is going to be in a perfect circle. That was an assumption placed on the universe derived from our own philosophical proclivities. In that case, a religiously philosophical proclivity. Mm-hmm. So, given this exercise, this failed exercise in the history of science, of which there are many examples one can give, I will not say that the universe can't be infinite.
What's in the middle of the galaxy? Because it looks like a light.
There's a black hole. Well, in this picture, the density of stars is way higher in the middle of the galaxy than out here.
Why?
We're figuring that out. We think in the formation scenario of the galaxy that most of the mass is near the center and it gets thinner as it comes out. And so we're going to have the most stars where the most mass is that you start with. So it's not a surprise that the middles of these things have the most stars because they have the most mass. And in the exact middle, in the center, is a supermassive black hole, which we've measured to be there. In fact, a Nobel Prize was given for that measurement.
Can you explain what a black hole is, like on 12?
Oh, yeah. You know, at first you got to respect black holes. Give them, don't ever diss a black hole because you will lose. So we're here on Earth, and the old adage, what goes up must come down, you've heard that. I would learn by the time I was 9 that that's just false. No, by the time I was 10. Because I was 10 years old, because that's how old I am, we walked on the moon. And then we left rocket parts on the moon. Mm-hmm. Those are never coming back to Earth. So there are things that went up that never came back. Okay? All right. Well, what started the adage, though? Well, if you take something and toss it, it actually slows down, comes to a stop, and then speeds up and comes down again. It's captured by Earth's gravity. Turns out there is a speed with which I can throw this so that it never comes back. Let's get there. If I throw this a little faster with more energy, it goes higher before it comes back, right? How about even faster? Even faster. It gets higher and higher and higher and higher and higher. You can calculate using physics and gravity equations. There's a speed with which this will go so high up, it'll reach infinity. If it reaches infinity, it's not coming back. That's called the escape velocity for Earth. How fast is that? It's really fast. Really fast. 7 miles per second. If I throw this at 7 miles per second, it'll reach the edge of the universe and never come back to Earth. Suppose Earth had more gravity than it currently does. Does it make sense that that escape velocity would be greater than 7 miles per second? Mm-hmm. If Earth's gravity were stronger, it might be 10 miles per second, 100 miles per second. Keep up this exercise. You'll reach a point where your object has an escape velocity that equals the speed of light. The moment it achieves that, light cannot escape. It's not moving fast enough. And if light can't get out, it's black. If you fall in, you are never coming out because you can't ever reach the speed of light. There's no greater definition of a hole than that. Hence, black hole. By the way, Einstein could have predicted them, but it was too weird for him to go there with his equations. We would learn about black holes mathematically in the 1960s, make our first discovery of one in the 1970s, a famous source of X-ray energy called Cygnus X1. And now they're common, and we've even discovered them in the centers of galaxies that have like 1 million times the mass of the sun. Monstrous black holes, dining on anything that comes close.
Just things that come close.
Yeah, it's not going to reach out. So if the sun were to become a black hole now, it won't reach out and grab us and suck us in.
Oh,
it'll have the same gravity as a black hole as it does as a star.
But it's if you go close.
Yeah, you can get really close to it, and then you're not coming out.
Is there a certain distance? Wait.
It turns out there is. There's a distance around every black hole. I think it's called the ergosphere. It's got a name where there are no stable orbits around it. If you get closer than that, you will fall in no matter what. Whereas beyond it, you can maintain a stable orbit and look at black holes from a distance.
And where'd you go if you get sucked in?
Well,
are you crushed or you?
Well, it depends how big the black hole is. Small black holes, that's all she wrote. Okay.
This one.
Oh, that one, you'll fall in.
And then where do I go? I'm just collapsed.
Well, there are books. I have one on my shelf, and I've even read it. It's a graduate textbook that describes the mathematics of space and time on the other side of a black hole. And it shows that a whole new space-time opens up in front of you.
What?
Inside the black hole.
What
the whole universe. The math shows that. Given the general theory of relativity, which gives us black holes in the first place, if you follow the math, you get a whole space-time that opens up inside the black hole. And as you fall in, your time changes. So time ticks more slowly for you relative to the universe. It's called time dilation. And so as you look out in the universe will unfold faster and faster and faster. And you will see the entire future history of the universe unfold as you descend into the black hole.
When you say descend, because I thought of it as like, if you go close to a black hole, you're going to be crushed into a small mass.
Well, I didn't get to that part yet. I'm describing what happens to space and time as you descend through what's called the event horizon. That's the region out of which you don't escape. That's the functional size we give to black holes. How big is its event horizon? You cross over within that volume, that's where the escape velocity is greater than the speed of light. And you're not coming in. So it has taken the fabric of space and time and folded it back on itself. So there's no pathway you can take to get out of a black hole. You're in there forever. And for the small black holes, here's an interesting fact. You don't think about this, but it's true. When you stand, your feet are closer to Earth's center than your head is. Okay?
Mm-hmm.
You can calculate what the force of Earth's gravity is at your feet and the force of Earth's gravity is at your head, and you'll get two different numbers. They're very close to each other, so we don't think about this. It doesn't matter to us.
Mm-hmm. But
as you descend a black hole, the difference in gravity between your feet and your head gets greater and greater and greater. They're called tidal forces, and they end up stretching you head to toe. And initially, it probably feels good, right? You just sort of stretch. And then you realize, oh my gosh, this is unrelenting and it's getting stronger. Eventually, you'll snap into two pieces, likely separated at the base of your spine, if you sort of look at the structural integrity of human physiology. And then you're still falling, and now those same tidal forces will operate on your torso and on your lower half. They'll stretch and they'll snap into two pieces. So you go from 1 to 2 to 4 to 8 to 16, and you'll bifurcate in pieces all the way down to the center of the black hole. The worst part is, well, maybe equally as worse, is you are occupying a narrower and narrower volume of space-time as you go down to the singularity that is the center of the black hole. So not only you get stretched head to toe, you're getting extruded through the fabric of space like toothpaste through a tube. Have a nice day. So, yeah, you don't want to test. All of our equations tell us that's what will happen to you.
What's at the heart of the black hole? You said
we don't know. So here's a problem. General relativity that gives us the black hole in the first place. If you follow the equations, the center of the black hole is infinitely dense and infinitely small. How does that even happen? We don't know. Maybe something prevents that. But that is the limit of Einstein's general theory of relativity.
One of the things you've heard me talk about quite a lot over the last couple of years, and this is something that's true in business and content, but also with everything in life, is that consistency is the thing that really, really compounds. The same is true in sales. When your team is small, consistency happens naturally. The team knows of every deal, so nothing gets missed. But as I've experienced, when you grow, this starts to break down and deals start to slip, follow-ups don't happen, leads go cold that shouldn't have. And when this happens, a lot of leaders look at it and think they have a people problem, when actually it's a systems problem. The businesses that I've watched scale well commercially all have a system their team uses every single day. And for my team, that system has been our sponsor, Pipedrive. It's an easy-to-use intelligent CRM tool for growing sales teams that gives you visibility of every deal in your sales pipeline at every single stage. And it shows you what needs to happen for that deal to move forward, all in real time. It's what keeps our commercial operation consistent when we're a team of 5 or when our commercial team was a team of 50. Over 100,000 companies are already running their sales on it. So if you'd like to join them, sign up at pipedrive.com/CEO, where you'll get an exclusive 30-day free trial instead of the usual 14 days. And there's no credit card needed at all. Head to pipedrive.com/CEO.
Xin chào mọi người. Chào mừng các bạn.
I don't speak Vietnamese, but this show can because of AI video technology from our sponsor, HeyGen. I get messages every single week from those of you listening to the Diary of a CEO all around the world, and you express how much impact it's had on you and your life. And if that's true, then those conversations shouldn't only reach people in English. HeyGen can take one recording of me and deliver it in any language while keeping my voice, timing, and expressions intact. But you don't need a studio like this to make it work for you. Record 15 seconds of yourself and get an AI avatar that delivers studio quality video in over 175 languages. We're up to 20 languages now, and we're not the only ones using it. HeyGen is already used by 30 million people, including 85% of the Fortune 100. Whether you're building an audience on social media, launching an online course, or rolling out training across your team, check out HeyGen now. Your first 3 videos are totally free at heygen.com/DOAC. That's HEYGEN.com/DOAC. See you there. So, aliens. In our galaxy, is that possible? That there's intelligent life in our galaxy?
I have no reason to doubt it.
Really? You think it's, on a balance of probability, you think it's more probable than not?
Oh, yeah. Just given the size, like I said, given the age, the size, the ingredients, how quickly life got underway. By the way, when you say intelligent, there's intelligent life on Earth. Like, do you know where we are in brain size?
Relative to other animals?
Yeah.
We're not the top.
Yeah, we're definitely not the top.
I have no idea.
Yeah, we're like 4th.
Okay.
There's the whale,
and
then the dolphin, and then the porpoise, and then the elephant, and then us. So if aliens came to Earth and they knew that brains are important, we'd be like 4th on their list for who they want to talk to. Just chew on that for a moment. Second, what we were told in school was, but if you take the ratio of the size of your brain to your body weight, we're at the top. Well, that's our ego speaking there. We didn't have the biggest brain, but we want to believe that we're smart. And so is there some math magic we can perform on brain size to put us back at the top of that list? Yes. Ratio the size of your brain to the mass of your brain to the mass of your body, then we're at the top. However, what they didn't say is that No, we're not at the top of that list. We're only at the top of that list among mammals. There are mid-sized birds like the magpie and the parrots, where the ratio of their brain size to their body weight is greater than that of humans. So look at the efforts we put in to just distinguish ourselves from all these other animals. And it's quite the exercise in ego stoking. You want to think you're special in the tree of life. There are birds that fly and we can't fly. Newts can regenerate their limbs and we can't do that. And so badly do we want to, especially with military veterans, right? Mm-hmm. With missing limbs and things. You want to regenerate that. We can't do. Newts can do that. Crustaceans can do that. We can't do that. So, might an alien consider whales to be intelligent? Probably. But we add extra elements to this. Do you have technology? The whale is not building telescopes, but we are. A whale doesn't, have art, but we do. All right. So we are a thing. We have what we call civilization. So if you want to ask, are there intelligent aliens that have civilization? That's yet another layer of that question. Is there intelligent life in the universe? Then you can ask, is there intelligent life that has civilization that has technology? Because the Roman Empire, they didn't know anything about electricity or computers or AI or anything. And if aliens were sending them radio signals, they're not sending radio signals back. So the operational definition of intelligence might include your ability to communicate across space or your ability to build a spaceship to move. The Romans were not building spaceships. So would they count as intelligence if that was an alien species somewhere else in the galaxy?
But is it plausible that there is intelligent life in this universe that hasn't got the capability of visiting Earth?
Yeah, sure. Why not? Sure. That's probably the standard.
How far can we gone?
That's a great question. The fastest spaceship ever launched was the New Horizons mission to Pluto. And one thing in space exploration, there's an unwritten rule. However you design the spacecraft, make sure it gets to your destination before you get old and die. Mm-hmm. So this spacecraft that went to Pluto was on the most powerful rockets available, and they made the payload as light as possible so it could accelerate. And so it got to Pluto quickly. If you instead took that and directed it to the nearest star, the Alpha Centauri system, instead of going to Pluto, at those speeds, direct to the nearest star, take you 50,000 years to get there.
50,000 years?
The nearest star.
To Earth?
Yes, to the sun.
And how many stars did you say there was again?
Well, 100 billion, hundreds of billions.
And the nearest one would take 50,000 years?
50,000 years to reach.
Gosh.
Because space is empty. Right. So maybe there are intelligent aliens out there, but space travel is too hard, so they haven't come to visit us. This is one of the hypotheses, because if aliens are everywhere, well, then where are they? I think they came to Earth and they saw all of our debris orbiting the Earth. There's a lot of space debris. And they said, I'm not coming. I'm not going to risk my life. And they just passed us by looking for another planet.
I've wondered about this space debris thing because it seems that every
it's
nation...
bad. It's worse than you think.
But what I was going to say is every nation now seems to be racing to throw tens of thousands of pieces of metal, satellites, into our orbit. Is it a problem?
Well...
There's no laws, is there?
No, you have to ask, who is it a problem for? Is it a problem? Yes. Who's it a problem for? Not the people who want high-speed internet in the middle of the ocean or in the Arctic or in the middle of the desert. Because these satellites, these SpaceX Starlink satellites, are providing that in these remote places of the world. So it's not a problem for them. It's a blessing. It's a problem if you're just trying to observe the night sky the way we've done as astronomers since time immemorial. And I'm trying to get images of the night sky and I see satellites crossing back and forth. This amounts to visual noise in my data. And if I'm trying to track an asteroid that might be headed our way and have thousands of other streaks of light in my image, there's a chance I might miss the asteroid. Also, if there's some object of interest and a satellite passes right in front of it, that will contaminate the data that I seek. I don't know if this is reversible, but what it tells me is that the future of telescopes are going to have to be spaceborne telescopes, which we've already made that transition, and or the moon, telescopes on the moon.
They've launched roughly 5,000 satellites objects into orbit in 2025. We're on track to launch even more than that this year.
That's correct. We probably already launched that by now. We're being recorded mid-year 2026. We're already high up there. So the last number I saw, SpaceX had 10,510 satellites.
There'll be 100,000 active satellites in orbit by 2040.
Probably more. This is the utility of space, not only for reconnaissance, for surveillance, basically military security, but also commerce. There is no Uber without GPS. So it's not the value of the satellites themselves that matters here. It's the value of the economies that they enable. And that's why we have a Space Force now. A Space Force which had been percolating for decades. Trump 1 decided, let's make this official. And so he did. So now we have a Space Force. And people say, oh, does that mean there's going to be like Star Wars and everything? There already was a Space Force. They didn't call it that. It was called the Air Force Space Command. It was a sector within the Air Force. And so you pull that out, now the mission is a little more pure about what its goals are and what it needs to accomplish.
Have you heard about Kessler syndrome?
Oh, yeah, of course.
Could you explain Kessler syndrome?
Oh, yeah. So 1978, I don't remember, he was a physicist or a mathematician named Kessler, who saw the increase in satellite launches that had been going on, and he did a calculation, and he said, there must be some threshold of satellites orbiting the Earth where if one of them gets destroyed by any means, maybe two collide with each other, or one is intentionally taken out by a missile, which has happened 3 or 4 times. China's done it, India's done it, Russia's done it, and we've done it 4 times. We've done it to our own satellites, which means what? Think about it. If you can do it to your own satellite, you can do it to anybody else's satellite. It's a demonstration of your sovereignty, in a way, of your powers over what you might perceive as an aggressor. Anyhow, if you destroy a satellite, let's say it breaks into 10 pieces, each going orbital speed. Orbital speed is 17,000 miles an hour. That's way faster than a rifle bullet. So little pieces of satellite can be far more devastating than a high-powered rifle bullet shot into another satellite. All right, so these pieces scatter. If any one of them hits another satellite, breaking it into 10 pieces, you go from 1 to 10 to 100 to 1,000 within just a few orbits. 100% of the satellites can be taken out if you have enough satellites for that thresholding to take place. So in other words, if low Earth orbit space is mostly empty and you destroy a satellite, the particles are not going to take out another satellite. They'll orbit harmlessly or fall to Earth harmlessly. But if you have another satellite in that path, then that destruction is going to take out other satellites. So he warned us of these thresholds. I don't think we're there yet, but we need to keep it on our radar. And the movie Gravity, it portrays exactly that scenario.
Objects in orbit travel at blistering speeds, 17,500 miles per hour.
Correct.
And at that speed,
just 5 miles per second.
At that speed, even a fleck of paint carries the destructive power of a bullet.
Yes, a rifle bullet.
Or an exploding grenade.
Correct.
A fleck of paint.
Yes.
Okay, that makes sense. So if there's one collision and there's lots of them up there, it's like shrapnel.
Correct. Shrapnel is the best analog to that, because it comes out and it damages other things beyond the target that was intended.
And there's no laws up there, is there?
Well, they're trying to, space law is a Wild West at this point. Forget orbit. It's like you go to the moon. Who owns the moon? Who owns a plot of land on Mars?
Nobody.
Well, they're trying to figure that out.
Really?
If I go to an asteroid and I want to mine it for its minerals, who owns those minerals?
So they're trying to figure out who owns the moon.
Well, owns anything in space. Anything in space.
Isn't it just who gets there first?
Yes, mate. That's what I mean by the Wild West.
At the moment, it seems like there's a race to go to the moon. A lot of companies are interested in that. We've got this Artemis program happening.
Mm-hmm.
The US seem interested. Why are people so interested in going to the moon? And is there merit in their motivations?
Well, we could have stayed on the moon in 1972, but we didn't. Could have gone in 1980, but we didn't. 1990, we didn't. 2000, no. 2010, no. Oh, what happened in the 20-teens? Oh, I know what happened. We learned that China wants to put astronauts on the moon. Taikonauts, they call them. We then say, hey, wouldn't it be good if we went back to the moon? That's an interesting idea. Let's do that. Happened under the first Trump administration. So the Artemis mission gets birthed. Artemis. Do you remember who Artemis was in Greek mythology? Artemis is the twin sister of Apollo. That's good. That is going to name a program. That's good. Twin sister of Apollo. So we say, we're going to go back to the moon. My read of that landscape is that China put a flame under our ass.
Mm-hmm.
No different, really, from when Russia first launched the satellite, Sputnik. Put a flame under our ass. Within a year, we created NASA. By the way, it may take just such a thing to bring Congress together for a unified project. Do you remember when we had the testimonies in Congress of the whistleblowers? We had Republicans sitting right next to Democrats asking questions about aliens. And so there's everyone paying attention to the aliens. I said, wow, Republicans and Democrats are agreed on some process in Washington. I thought that was a beautiful fact.
So what are our motivations now to go to the moon? Is there an economic upside to it?
No, it's geopolitical. China says they're going to the moon. 50 years after we go to the moon, and we all of a sudden decide we want to go to the moon. Let's be real about that. And while that came out under Trump, Biden comes in, we keep the program. Biden could have said, oh, this is a Trumpist thing. I don't want to do, he could have done that, and what would have anyone said? But he didn't, because NASA is a geopolitically responsive organization.
So what if China get there first? Why does that matter?
They're geopolitical egos.
Just ego.
Yeah. I mean, did you see the hearings in Congress with the head of NASA when they're asking, why did China land on the far side of the moon? What do they know that's there that we don't? Okay. This is the competitive urges that we have. And don't delude yourself into thinking we ever went to the moon for science. Then or now.
What about resources? Is there resources on the moon?
We're looking for them. NASA has an entire branch of itself called In Situ Resource Utilization, ISRU. You go there, we think there's water at the South Pole. So you go get the water. Maybe if you get a 3D printer, you can take, the silicates from the moon's surface, dump it in on top and make tools, whatever. That would be interesting. There's a whole piece of space exploration that concerns itself with that, because you can't take everything with you.
Is it cold on the moon or hot?
It depends on if you're facing the sun or not. Because we say, is it cold? You're generally referring to the temperature of the air around you. That's what you mean. Oh, fix the thermostat, change the air temperature. Where there is no air, your temperature comes from any source of or absence of a source of energy. So if you face the sun, this side of you will burn up and the side of you on the other side will freeze. So what we really need are rotisseries or a highly insulated spacesuit.
Do you think in my lifetime, it's 3 days away, isn't it, the moon?
Yeah. So you can get there quicker, but the minimum energy to do so will take you 3 days.
Don't you think that would be a great tourist destination?
Of course. Completely.
3 days.
I would save up multiple years of vacation money to go to the moon. Yes. completely. If you can bring the price of that down, make the moon our backyard. So what I wanted to be clear earlier when you says there's economic reason to go to the moon, not initially, until you set up bases and hotels and restaurants and this sort of thing. And if you have restaurants, that'd be really weird food that they would serve, right? Like in moon gravity.
I travel all the time. I made a rule in my life that I'll only travel with a cabin bag. The problem with this is there's not much space. And here's the solution. It is called an Extra 1% travel pack. And I teamed up with Extra to make this. Typically, I can only bring some of my black shirts. And it's a trade-off of which black shirt shall I bring? How many of these do you think I can get in here? So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's try 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so that's 24 black t-shirts. Here's where the magic comes in. You zip it up, make sure it's nice and sealed, and then you use this little contraption. Stick it on there. I can now take more than 20 black shirts with me, which will last me 3 weeks. So if you travel frequently and you want to get one of these so you can save more space and be away for longer, go to extra.com and use code DOAC for 10% off our collection. The UFO files, I'm presuming you've seen all the footage that's been released.
Most of it, there's a redundancy after a certain point.
I mean, it's this kind of stuff where they're showing objects flying through space.
Typically, it's monochromatic and very low resolution, as this is. That's correct.
Was any of it compelling to you?
No, it's something that we don't know what it is. Let's back up. Even UFO enthusiasts of the most severe kind would agree that most sightings of what we call UFOs have natural explanations. That you just didn't know what you were looking at, and then you figure it out later. Is it a cloud formation? Is it lightning? Is it twilight conditions? Sure. But then there's some that no one knows how to explain. I don't have a problem with that. There's some that are sort of interesting. I like the Tic Tac. Tic Tac is fun.
Oh, yeah, the Tic Tac.
The famous Tic Tac.
What's interesting about that?
Well, because I don't know what it is. I'm a scientist. We are attracted to things that we don't know or understand. Attracted to them. It's cool. Yeah, there it goes. Yeah. And you can see it move in one of the frames. And you can see it sort of gimbal in one of the frames. So let's see, it's coming up in just a second. And of course, it's combined with the statements of the pilots, how shocked they are and how surprised. There it is. That's kind of fun. It looks like one of the alien spacecraft that Steven Spielberg showed in Close Encounters of the Third Kind. But that's not what intrigues me. What intrigues me is we have whistleblowers saying we have actual aliens. So give me the actual alien.
Do you think if we did, we would tell the public?
People have testified we have aliens, that we have alien crash parts, that we have reverse engineered alien technology, that we have no end of movies portraying aliens. And somebody says, oh, we're not ready to see an actual alien. Of course we're ready. Hollywood has prepped us for decades for this day. I think it'll be charming. What would surprise me most is if the alien were humanoid. Most Hollywood renderings of aliens are humanoid, with a head, 2 eyes, a nose, mouth, ears. Oh, they're bald. Okay. Or they're pointy ears, but they're still walking, and they still got elbows and fingers and knees and
like this.
And
I mean, we've got ones like this as well.
Yeah. Okay. So there's a good ET. This looks like the xenomorph, and this one looks like Predator. Okay. So notice, they all have eyes. There's a mouth. There's teeth, because teeth are scary. And this is humanoid. These are humanoid. This is a little more reptilian, I would say. It's definitely vertebrate, but it has a tail. So these are humanoid characters. I would be most surprised if the alien was humanoid.
What would you expect them to be based on the atmosphere of the universe?
I would expect it to not be humanoid. Most life on Earth is not humanoid. And we have DNA in common with all life on Earth. And most life is not human. Oak trees, worms, lobsters, none of those life forms are humanoid. And so here we are. We have, oh, by the way, the xenomorph is not building spaceships. So if this comes to Earth, it's because we brought it here, not because it flew. Okay. Based on its conduct, it looks like it just want to be parasitic. E.T. has fingers, and it looks like E.T. can build a spaceship. And this is just a hunting mission with the alien. Notice that its eyes are even the same separation of our eyes. And so there's an actor in this costume, and the actor is human. That's really what this comes down to. Yeah, that's good photos you got here. Oh, hey. So in the book, I didn't come up with these. I stumbled on the fact that people who care about sightings, not UFO sightings, alien sightings, people who've said they've seen aliens. By the way, like I said, that whole exercise didn't reach the fever pitch until you had whistleblowers saying they've met aliens under oath in Congress, and not the drunkards coming out of the bar at 2 a.m. Okay. So they divide into archetypes. So little green men, that's, we had a lot of those back in the 50s and 60s. And, of course, the fact that we would even use the adjective men meant they're humanoid. Okay. Little green men. So that's one variety. Another one, what do we have here? This one is much more common today. The grays. Okay. The gray alien color. These also tend to be bald. So these are the two most common. And then there are others. Arcturians, they're from the star Arcturus. Lyrians from the constellation Lyrae, the harp in the sky.
We'll put these on the screen for anybody.
Sirius is aliens from the star system Sirius. So in my book, there's a dozen of them. Oh, the tall whites. Oh, insectoids. This is a good one. I love this one because we hate insects. I can't speak for everyone. Insects are ugly to most humans, right? So if you have a creature that resembles an insect, you don't want to become friends with it.
If you listen to people that have done DMT, they often they often cite seeing or meeting these types of
and the commonality of that is intriguing. Rather than jump to a conclusion that they're all having some common interdimensional experience, it's easier for me to think that they all have human brains and the chemical is exciting the same part of each one of their brains, and thereby sharing in some experience that, and plus people, I don't know if they've done this across cultures. The English-speaking cultures have reported many more alien sightings than other cultures. Vastly more sightings, which is a little weird. So either aliens just like visiting English-speaking countries, or we just know better how to report what we see, which is probably what it is. But you go to other countries, they don't have this alien fixation.
Have you ever done psychedelics?
Never.
Are you curious about it?
Not really. Because the human brain barely works as it is. Barely. Just open up any book of optical illusions. Turn to any page. Oh, is it bigger or is it smaller? Is the line in the page, out of the page? I can't figure it out. Simple drawings confound your perceptions of reality.
But doesn't that mean that reality is fragile?
Yes. And so if I want to now stir chemicals into my brain as a scientist who values what is objectively true, since my brain barely works as it is, to put in chemicals, it's not clear to me that that gets me closer to any reality at all. And it's reality that I value in this world. So that's why I haven't done psychedelics.
What I think about is if I can inhale something and suddenly my subjective experience of reality is entirely, it's 4K and I'm somewhere else, does that not then mean that my current subjective experience of reality is as fragile as an inhale?
Sure.
And then,
well, it's chemicals. So it's a reminder that your brain functions based on electrochemical signals. But does that mean, and to put some other chemicals in there to disrupt it, to rechannel it, sky's the limit.
But does that mean that reality itself is just a bunch of chemicals?
There are philosophers who like thinking about that and debating it and arguing it. I tend to be way more practically minded in that conversation. Okay? In that I can perform an experiment outside of your five senses, and it will get a result that everyone coming together to look at that result will agree on.
That's one of my senses, though, looking.
Sure, but if you don't have that sense, then you can't participate in that exercise. I'd find some way for you to then be able to identify it. But I can create a measurement of ultraviolet light. You can't see ultraviolet light, but I have a detector that fires, and you can look at the detector firing. Okay? And so there it is. I've measured ultraviolet light, and I didn't need your eyes, your retina, or your brain to make that measurement. So when Einstein said E equals mc squared, and that became the foundation of atomic weapons that we then drop in warfare, killing tens of thousands, hundreds of thousands of people, you can't tell me, oh, it's just our imagination. Oh, that's just chemical thing. That is a real phenomenon based on real physics drawn from an objective reality that we established while not doing drugs. And so that's why it took so long to develop science, to separate measurements of an objective reality from the neurochemical synapses of your brain.
Isn't it all, though, observation? Isn't that what science is?
Yeah, so if I can have a device that makes a measurement, and most people look at that can agree of what that thing is. If I'm a betting person, I would bet that that is a representation of objective reality.
So we can measure our current
If I bring
reality.
a completely crazy person to it, they're not going to know how to. And so how do I value their interpretation of the data? And is it subjective? Are we the crazy ones, and is that person the normal one? Right. So these are legitimate questions, but they're answerable using the methods and tools of science for what is repeatable in this world and what is not.
And this world is a experience manifested by the chemicals in my brain. So we're measuring this reality that we live in.
If you inhale something and there's a whole other reality, well, you're right now inhaling oxygen and you have this reality. How many other realities can you visit?
Yeah.
And which is the real reality?
Yeah.
And all I would say is, I make mention of it in the book, people on DMT have these shared experiences. So let's do experiments on that to see if can one person experience an insectoid, glean information from that psychedelic alien that matches someone else's information. That's how you would probe this. Otherwise, you say, oh, it's real, and then we'd start a new religion. I can tell you that if there was a drug that if you imbibed it, and by whatever means, if it got me closer to an objective reality, I would do it.
An objective reality?
Yes.
Yeah.
Yes. Like I said, the brain barely works. Now, is there a better objective reality? Well, that's why we have science. I have tools that measure infrared and ultraviolet and X-rays and gamma rays and magnetic anomalies and electrical currents. And I can measure all these things. And your brain is irrelevant to those measurements.
I had a physicist come on and he said that we can only see that which we need to see in order to survive.
Mm-hmm.
And thus, if you look at a bat or another species of animal, even here on the Earth, or a dog.
Well, evolutionarily.
Yeah.
Yeah.
So theoretically, there could be spirits in this room now, but because they're inconsequential to my survival, I actually don't even need to be able to see them. I didn't need to develop the senses to be able to know that they were here.
That's why science has dozens of senses. We've gone beyond human physiology in the sciences. So that's why I don't have to have that conversation about my reality versus any other alternative reality and which one is real. That's why science exists. We have the microscope that gets us into the realm of the small, the telescope that gets to the realm of the large. Your senses have no access to either of those places. The Dead Sea in the Middle East was called dead because there were no macroscopic fishes there, because the salt level is so high. But their microbes do in the backstroke. Okay? And salt-resistant microbe. So they couldn't see those, so their reality missed something. Yes, your reality is going to miss things that are not otherwise going to put your health at risk, evolutionarily. But science changed that forever. Deal with it.
I was going to say, yeah. I mean, a lot of it's predicated on, believing in my observable experience. And
you don't have to, because like I said, we have tools. That's why I can look in the sky and say, wow, what is that? I don't know what that is. I pull up binoculars, tools. Oh my gosh, it's a drone. And I can see it better with higher resolution and it's brighter. Oh, what is that over there? I don't know what that is on the horizon. Oh, it's a bear crawling on the side of the thing. It's not some alien. You bring out the tools, supplement your senses.
And these are all observational tools.
Those that I just mentioned, yes. But there are others that you can test things without observing them. You can look at what effect they have on something else, for example.
If a couple of chemicals are responsible for this entire experience, like the things that I feel, touch, smell, hear, is it plausible then that actually...
It's more than a couple, but your sentiment is accurate.
Yeah. Is it then plausible that we are just a bunch of chemicals in a petri dish somewhere that are creating a subjective experience, and that subjective experience manifests as a universe that I can see, this iPad that I can touch, but actually we are just a chemical reaction in a petri dish that some aliens are doing? Because if chemicals are my entire subjective experience...
It's way more likely that we are just a simulation.
Yeah, I think we probably are a simulation. I think I've concluded.
Based on what you just said, if we have to be in a petri dish, it's more likely that we're simulated by some snot-nosed kid in its alien parents' basement.
That was a biological simulation I described.
Yes, it was. So, like I said earlier, the laws of physics are different on different scales. You can't just put us in a petri dish and have us behave the way chemicals and microorganisms would behave, like bacteria, that sort of thing, would behave in a petri dish. Petri dish is ideal sized for bacteria, not for us in some larger petri dish. No. We function differently with our environment than microbes do in a petri. You can't just scale it up as much as people would want to. That would make everything easier. We're just nested dolls.
Do you believe that we're in a simulation? Do you think it's plausible?
I don't want to believe it.
You don't want to believe it?
I don't want. I'm whiny about that.
Why?
Nobody wants to be a simulation. My best argument that we're not, or rather, my best way to improve the odds that we're not, is just to remind you how the simulation argument works. You have some universe, and then they have computers that are very powerful. They simulate a world within the computer, and the life forms in that world believe they have free will. So there they are. It's like a video game, right? And then they are, and then they say, I'm bored, I'm going to make computers. So they invent computers, and then they create a video game inside their computers. And then it's video games all the way down. Okay? Okay. So if I close my eyes and throw a dart, which universe am I most likely to hit? The one that started them all, or the 999 bajillion that followed? Probably one of the ones that were manufactured, which argues strongly that we're in a simulation. However, the only universes that could create other worlds are the ones that have the capacity to create other worlds. Okay? So each one of these in this sequence had the computing power to create a whole other world. That's why it continued the sequence. We, humans on Earth, do not yet have the power to create an entire other universe with people in it who have what they believe is free will. We don't have that power yet. Because of that, we are not one of the ones in the sequence, because everyone in the sequence has the power to create another universe, and they did. We don't have that power, which means we are either the very first universe in that sequence or the very last that has yet to achieve the power of simulation. So we go from, 100 bajillion to 1 likelihood that we are to maybe 1 and 2. And I like those odds.
Does this not assume that the creators of the simulation modeled their universe as being a one-to-one copy of our own, and they wanted us to have...
No, but they can make any kind of universe they want. Who cares? Not a one-to-one copy. This universe happens to have like planets and stars and people in it. The other one could just be Mario characters.
Probabilistically, I think I've heard Elon Musk say that he thinks probabilistically this is a simulation, which I thought was compelling. And he did reason that, they've got these three potential options. Either humanity just blows themselves up before they get to this technological advancement. Either this is a simulation, or either this is space reality. Those are the three plausible outcomes. And one would say, it being base reality is highly improbable. Do we blow
Why is that highly improbable?
The size and scale of the universe and the speed in which we've gone from being like, frankly, relative speed of cavemen to being able to do large language models of vast intelligence and VR simulations. It's like this Cosmos taught me this. It's like this.
Well, it's actually not like that. It's not. Can I explain why?
Sure.
Okay. So it's simply exponential growth.
Mm-hmm.
That's all it is. So if you plot Earth's population, very common encounter with an exponential curve. Okay. So you have a plot and you have time. Go back. I don't care how much time it is. You go back and it's like almost flat line and then it goes up. This is what you're talking about.
Yeah.
It happens like this. That is the plot of an exponential on linear graph. Okay.
Mm-hmm.
Here's what all exponentials have in common. If you truncated it somewhere here, let's say, so go back 20 years, 30 years, 50 years, and then replotted it, it would do this.
Mm-hmm.
Go back again, replot it, it would do this.
Yeah.
Everybody in an exponential thinks they're living in special times.
Yeah.
They think that all the greatest, most important discoveries happened recently. Yes, that is true, but it's true for everybody along the exponential. When we invented the car, the automobile, no one is saying, look how backwards we are. They're saying, look how advanced we are. We now have an automobile, and we have railroads that cross the lands, and we have steamships that cross the ocean. Look at how advanced we are. Look how far we've come in just decades.
If you imagine any rate of improvement at our current trajectory, we get to a point at some stage in the future where we can create simulations.
Yes. Yes.
So
it's a natural.
Yeah, we
yes.
get there.
But we're not there now. And since we're not there now, we're not one of these middle universes.
But whether it's 100 years or 1,000 years or 10,000 years, we eventually get there. And then if you layer that over with what you said about there being 100 billion galaxies with 100 billion stars, it's conceivable that we are not at the front of that race. And if we're not at the front of that race, that means that someone else theoretically got there at some point, and therefore we might be their simulation.
Yes, of course. Yes.
And that seems way more
No. What I'm saying is,
yeah,
yes, we could be their simulation, but we can't simulate anybody within our world yet.
Yeah, not yet.
That's why we are either the last one in that list created by some other civilization that can't yet create the next civilization, or we're the first one that's authentic.
Or it could be a tree though. It could be like they did 500, then this person here did 300.
Yes. So I'm taking the very straight line model.
Yeah.
Yes. It could be fully branched out.
Yeah.
And sure. All I'm saying is we're nowhere in the middle of that. We have to be at the end because we can't make another universe yet. So that greatly reduces the total number of universes your dart can hit when you toss it against the wall. You're either the first universe or the last one. And I gave it in a line, but it could be the last of any of these.
Yeah,
yes.
It could be the last of a tree. Like I think a family tree. You don't have kids.
That's fine. So how many would the last be? 500, 1,000? Whatever that is, there's countless other ones that came before us leading up to that.
And we could have cousin simulations that went on, and that seems more probable in the balance of. I can't think of a singular argument that's more convincing that, okay, if humans eventually get to technological advancement, thus so that they could create their own simulation, then it's conceivable that in such a vast universe, other living intelligent life got there first. You agree that there's intelligent life in the universe. I think it's quite arrogant of us to think that we are the most technologically advanced in the universe.
Right. No one should be thinking that.
So thus it's a simulation, Neil.
Unless we are not the simulation and we're the original universe that hasn't started the ball rolling yet.
And could you imagine the odds of that? What would the odds of that be?
This is my point. The simplest way is to look in the line. in the straight line example, which we can spread out in just a moment, we're either the starter universe who hasn't figured out how to make a universe yet.
Yes.
Or we're the last in that line, which have yet to evolve the capacity to make a universe, because it doesn't happen instantly. They have to invent computers, and they have free will, and so they're doing their thing.
Yeah.
Okay. So however many universes are in between, it goes from that number of possible universes we could have been to a 1 in 2 chance that we're real. 1 in 2. We're the original, or we're this one, which is simulated. That's a 1 in 2 chance. Now you have branches. Fine. I don't mind branches, where each one creates 10 universes. Fine. You have branches. Once again, we are either the last one in a branch, or we're the first one that started it all.
Here's my drawing of how it might look. So we could be that one, or we could be that one, 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 that one. Why is that not plausible? It's kind of like a family tree. Some of them have kids, some of them don't.
So in that case, only one of them evolved to make another universe.
This one did here, but also this one did here.
Right. That's the only one in that generation that made another universe. Correct?
And this up here at the top.
That one made 10 of 8 of them, and only one of them made another universe. Okay, now 2 of them made another universe. Okay?
Yeah.
Okay, that's fine. Okay, so now...
And one of them made another universe as well.
Okay, correct. So you keep doing that. If we're early in the game...
Yeah.
Then we could be any one of those at the edges of the line. That's correct. Okay, we could be any one of those. And we're plodding along. But if all the rest make more universes, we know we're not them, because we don't have that ability yet.
Mm-hmm.
So, in your top row example, if one of them continues to not be able to make another universe and the others do, once again, in that case, is 1 out of 3 chance that we're real, that we're the starter universe, because you have 2 other places that have yet to make in another drawing that you could draw. All the rest make new universes, but 2 don't. In the simulation scenario, yes, you could do that, but that's not what anyone is thinking about. They're thinking that it's simulated universes all the way down. And you just drew a whole crop of universes that are not simulating other universes.
So
that's not very fertile in the simulated universe.
Maybe this is what the multiverse is. Maybe this is what infinity is. Maybe this was what the Big Bang was a universe creating the next universe.
Yeah, well, that's what we call it, the multiverse, creating universes.
And maybe that's what it is. Maybe the civilization becomes so advanced in their technology that they're able to create one of those Big Bang moments. And
yeah, I mean, that would be interesting if they just summon it up at will. Yeah, that'd be weird.
Maybe the point in which we, as an advanced civilization, can come together with, I don't know, AI and build a new universe is the next Big Bang.
There's no reason to say it couldn't be that. All right. But what's interesting, though, is that the laws of physics we measure on Earth apply across the universe and across time. So that's just an interesting, maybe that's just the programmer's rules for the universe they just created. So I have no way to step to the side of that argument.
So do I get a Nobel Prize? What happens now?
So the difference is, in our Big Bang, we went through single-celled life, then multicellular organisms, and then intelligence, then technology. So if the technology, we have technology that enabled all that. And in a simulation, let me back up. So in a simulation, are they starting you from the beginning of the universe? Is there a Big Bang in the simulation? Or are they just people just showing up fully formed as an intelligent species in the simulation? And maybe they're implanted with a memory that's not real. This is very matrixy.
What is the point of life? What is the point of all of this stuff? You get to live, I don't know, 80, 90, 100 years, whatever it is. What is the point, Neil?
The point.
The point of all of this. Why are we here?
So that question asked by many people will keep religion in business for a long time. For many, the purpose in life is to serve God. Okay? And that's a little odd to me, because if I created a universe, I would not need people to praise me. That just feels weird. I would just create it and have fun. Let me work on the next universe now. Personally, I wouldn't feel that need. So it's odd that a all-powerful, all-knowing entity seeks your submission and obedience. And it's just, I've never fully wrapped my head around that idea. But the meaning in life, it was really what you're asking. What is meaning? I derive meaning from life. I create meaning from life. When I say I derive it, I create meaning in life. I don't look for meaning. Many people look for meaning. Is it under a rock behind a tree? I'm still in search of the meaning of life. You realize you have the power to create meaning? Create meaning. We all have the power to do so. Add it to the meaning that you're looking for, but right now you can create meaning. One way is, this might not be the recipe for everyone. I want to learn something today that I didn't know yesterday. I want to learn something tomorrow that I didn't know today, thus growing my awareness of the objective realities of the world. That's my first. As I grow my awareness, I have new, nuanced, informed perspectives. So you can grow in wisdom, knowledge, wisdom, and insight that wouldn't otherwise be possible if you didn't keep learning. Second, I want to do something today that lessens the suffering of others.
Why?
Because if I have the power to make the world a better place for me having lived in it, I value that.
Why?
I value happiness because apparently people like being happy, unless you're clinically depressed. Happiness is something that I valued my whole life. It brings joy to being alive at all. So that's how I think about it. And in my podcast, the humor is an important element of the podcast. There's a braid of science, pop culture, and humor. People return. They come back to the podcast because they laughed, they smiled, they felt good at the time they learned the thing that they learned, and they want to reproduce that feeling. So we should not be surprised that we want to do things that make us feel good. And again, why does helping another person make me feel good? It's not, I don't do it for me, I do it for the person. Okay. I don't help the person across the street so that I feel good about myself. I help the person across the street so that the person feels good that they made it across the street.
Which in turn makes you feel good.
Well, except I don't want to be needlessly semantic. There are things that I could do that make me feel good that I don't do because it doesn't spread the goodness. I can live in my own, this feels good. But when you spread it, then other people can share in your emotions. And so I don't do it so much for myself. I just do it because I think we should spread more joy in the world. Here's a way to do that. Again, it's not about you, right? It's, I do you a favor. And you say, thanks, I really needed that. I'll repay that favor one day. And I'll say, no. Pass it forward. Do that favor for someone else, ideally a stranger, okay? A stranger who will never remember your name. Do it for them. And you know what'll happen? That favor, and you tell them to pass it forward, that favor will work its way through society, through cultures, through civilization, never being closed back. The moment you say, hey, I'll repay you the favor, that closes it off and it's no longer available to anybody in civilization. If you don't close it, send it forward, then there are these tributaries of favors working their way through civilization. And everyone is better off for it.
Neil, we have a closing tradition where the last guest leaves a question for the next, not knowing who they're leaving it for.
Oh, sure.
And the question left for you is...
Do they know it's me?
They didn't know it was you.
Okay.
What is it that you would like us to write on your gravestone if we were the authors of the message?
Let me back into that by saying I don't need anything that memorializes my life. Because it's not, as an educator, it's not about my life. It's about the life of those who I've touched. It's about their lives. It's not about my life. No statues, no plaques, nothing. I don't need that. I don't seek it. I've had photographers come up to me and say, oh, I'm a fashion photographer and I photograph all these famous people. Do you want to be a part of that? No. It's not about me. I don't need you to look at a picture of me in a book. What I want you to do, open up a book that I wrote and read what I wrote in the book. And you read that and you will learn from it. You'll be enlightened because as an educator, it's about you. It's not about the educator. So I don't want memorials or anything. Nothing. But I know what I want on my tombstone. There's the full quote, which I will begin with, but it's the end of the quote that fits the tombstone. It's by Horace Mann, the educator, American educator of the early 19th century. He was a university president. The school's named after him, Horace Mann School. He's an educator. For one of his farewell addresses at a university, he said, I beseech you to treasure up in your hearts these, my parting words. Be ashamed to die until you have won some victory for humanity. That's what I want on my tombstone.
Be ashamed to die until you have won
some victory for humanity. And as educator, that's my goal. Humanity's better off for me having been in this world. That's my goal. Because there are too many people where humanity's worse off for them having been in this world. Well, not too many. There's a few key people in the history of the world for whom that's true. And if we can do our little bit to improve the world.
You've most certainly done that. You've done it for arguably hundreds of millions of people. I think if I was really thinking then of like, what is the net impact you've had on my life from...
On your life?
On my life. From, all of the content and information and movies and books and documentaries and so on that you've written. And I think the net impact, if I crystallized it down to a word, was about curiosity. And I'd say it's like expanding my mind to what is to wonder more.
Unfortunately, that does not exist in most schools.
Yeah.
The kids in their class, they can't wait until the end of the period. They see the clock.
Mm-hmm.
They can't wait till the end of the school day. They can't wait till it's Friday. They can't wait till it's vacation. They can't wait till school's over.
Mm-hmm.
They can't wait till graduation. All of these sentiments are I don't want to keep learning anymore. It's a chore. I don't enjoy it. I don't like it. Well, there's even a rock anthem celebrating that fact by Alice Cooper. It says, you know it, school's out for the summer.
I think this photo and what you said about
school's out forever.
I hated school.
But it's my point.
Yeah.
I don't blame the students.
Yeah.
I'm blaming the system where you can't wait to get out of school, which means they're not teaching curiosity. Because if they did, staying in school would be fulfilling that. And if they did, leaving school would birth you the rest of your life as a curious person where you continue to learn. That's what school should be about, and it's not.
And that's what you're doing for others, expanding the curiosity, the aperture, and allowing them to wander beyond the narrowness of whatever.
I want people to say, gee, I miss school.
I don't miss school. I absolutely don't miss school. But do you know what I do miss? Well, I don't miss it, but we have to make a distinction between school and education, or school and learning. And we kind of conflate the two and think they're the same. So,
well, because school's got a bad name. It's got a bad, it's a place where you go to have curiosity fulfilled, stoked and fulfilled. That, if all schools were that, imagine how different the world would be.
We can only imagine.
Imagine.
I have your book in front of me here. It's, by the way, it's beautiful, and the title is great. It's called Take Me to Your Leader, Perspectives on Your First Alien Encounter. If you've ever wondered why there are so many UFO sightings, whether aliens might already be amongst us, Tyson offers an informed perspective that is both factual and fun. Take Me to Your Leader is a tantalizing exploration of what would be the most mind-blowing experience of your life. The book for anyone who has ever wondered, as we all do now, are we alone? Thank you so much. I'm going to link this book below. Anybody that's into the subject matter of aliens and wants to wonder and have some fun.
And if I can give you just my favorite example from the book, on the chapter Alien to Us. There's Alien to Us and Alien to Them. Whole chapters, right? Like little things like, let's say you befriend the alien and then you say, excuse me, I have to lay down horizontally and go semi-comatose for 1/3 of Earth's rotation. They'll look at you and say, what? What? You guys don't sleep? What sleep? I mean, it could be that. It's, you be ready that things we take for granted might not be obvious to an alien. And another one, if the alien has some appendage, right? Don't just reach and grab it and shake it. You don't know what part of the alien that is. And maybe you don't want to find out after you just shook it. And shaking hands is not even earth-wide. In Asia, shaking hands is not as common as it is in the West. So don't take your own, one of the biggest lessons there is don't take your own assumptions and apply it to the alien. And in the Alien to Them chapter, it's a fast one, and then we can wrap. Just imagine they landed in Los Angeles, okay? And they're in the median of the 405, right? And they're just looking around. I'm certain they would conclude that the dominant life form on Earth was the automobile. Because there they are just doing things. And then they'd see like a car hauler go by. And they'd say, that one's pregnant. They would see cars inside. If there's an accident, other automobiles come up to take it away and repair it. These automobiles go up to fast food establishments, and people don't get out of their car to go in. They stay in their car, wait in line, in a slow line to get fast food handed to them through a window, and then they eat it in the car. So the aliens would say, okay, the life form is the car, and the squishy things inside, that must be the squishy middle of this life form. What this book tries to do is recast all of your assumptions about what an alien would think of us and about what we would think of an alien. And I try to have fun doing it along the way. So that's all. Thank you for bringing it up.
Thank you so much, Neil.